Please watch how to rig and animate a car video, as this tutorial uses a rigged and animated car from an earlier project. The link is in the description below. So let's take this data. So this animation is for 5 seconds, so 120 frames at 24 FPS. And let's select the camera and let's delete the keyframes for the camera because we want a constant focal length for the camera. Cool. That's sort of the look that we are interested in. Perfect. Now let's change the frame rate to 240 and therefore the end frames to 1200. But wait, why do we need 240 FPS? It's because we need slow motion. If we run Mantaflow simulation at 24 FPS, it just looks blocky and discontinuous. And this is an example if we run at 240 FPS because there is 10x more data from the simulation. So now, in order to do this, let's have our pointer at frame 1 and then select each of these meshes or objects and then scale them on the x-axis on the timeline. While my pointer is on frame 1 on the timeline, and let's select each of these objects and then press A by selecting all the keyframes while the cursor is on the timeline, and then press S to scale and X on the x-axis. And then let's scale them up so that the end frame is at frame 1200. So that way, all the keyframes are scaled proportionately on the timeline. So that way we don't need to rerun the animation. I'm simply doing this because I wanted to use the same car animation data that we already have from our previous tutorials. There we go. So all the data has been nicely scaled to 1200 frames. So we scaled the timeline for the empty and we scaled the timeline for the car rig as well. So those are the two items that were animated. So let's get back to the object mode. And then let's view the viewport render. So that's 1200 frames playing at 240 FPS. And that looks exactly like 120 frames at 24 FPS. So our scaling worked as we wanted it to. During a drift, the smoke source is going to be the tire, but the tire has a dense mesh. So let's create a proxy mesh to use as a source. So for that, let's change the origin of wheel to its own geometry. And then let's add in a cylinder with 32 faces. And then let's scale it down and then snap it to the wheel's origin. We can do that by pressing Shift S and then selection to active. And let's get into edit mode and delete the faces on either side of the cylinder so that we're left with the faces in the periphery. And then let's scale it down so that the proxy mesh is just a bit larger than the wheel and that it's slightly below the ground plane as well, because we're going to use it later during the dynamic paint. Cool. Now let's parent the proxy mesh to the wheel because we want it to move with the wheel. There we go. Now let's move to the physics tab. And then while the proxy mesh is selected, let's click on fluid. And then let's change the type to flow. And then the flow type is going to be smoke. And then flow behavior is going to be inflow because we want the flow to be continuous. And then sampling substeps as 5. and then flow source as mesh, and then check the planar box because the mesh is planar. And then surface emission, let's put it at 0.5 because we want the smoke to be produced close to the mesh surface. And then initial velocity, let's give it initial source velocity of 50% of the wheel because we want the smoke to be behind the wheel. So let's give it half the velocity. So those are the settings. And once you have the settings, we're just going to duplicate it and then move it onto the other wheel. So we have two proxy meshes generating the smoke. And let's do the same thing, parent it. There we go. So now we want the flow behavior, the inflow, to be keyframe, as we want the simulation to start at frame 250 and end at 750. At frame 250, let's check the use flow and then insert a keyframe. And then at frame 249, let's deselect the use flow and then insert a keyframe. And then at frame 750, let's deselect the use flow and then insert a keyframe. So effectively what we're doing is all the frames before 250, the smoke is not generated, and between 250 to 750 frames, the smoke source is on, and then beyond frame 750, again, the smoke source is off. So that way we have the drift smoke only during the part of the drift which is between 250 and 750 frames. And then let's repeat the same process for the other proxy mesh as well. In order for the smoke not to pass through the car, we need to select the car body and add, under physics properties, add a collision to it. And these are the settings. They're mostly default. We need to create a domain, and we can do that by just adding a cube and then scaling it and then resizing it as it fits our scene. And then to this, let's add a fluid in the physics properties and change the type to domain, and then domain type as gas. And then resolution divisions, I'm going to use 1024. I'm not going to worry too much about the high resolution division because I'm going to use adaptive domain. And I just scaled the domain to that particular size because I don't want the domain to extend beyond what it's necessary for the simulation. And as I want the simulation to start at frame 250, I chose that location and the size for the domain. Alright, so let's leave the defaults. And then let's check the adaptive domain checkbox. Cool. And then under gas, let's change the buoyancy density and the heat to 0 because we don't want the drift smoke to rise fast. And we want the vorticity to be a bit high at 0.1. And the frames to dissolve in 20 frames. And the slow box is checked. And if you want the drift smoke to dissolve slower, we can just increase the time from 20 to something like 100. And let's check the noise box and then upraise the factor to 3 as we're gonna get some close-up shots. And the strength, scale, and time are gonna stay the same at the default. And then let's change the cache directory. And then frame start is gonna be 1 and then end is gonna be 1200. And then we change the type to all, and then we're gonna have is resumable, and format I'd prefer unicache. And then hit bake all. Now let's press escape and cancel the bake in the middle just to ensure that everything is working properly. We have the smoke extending far below the ground plane, which is not what we wanted. So let's move the domain a bit upwards on the z-axis, but ensuring that the domain extends just slightly below the ground plane. Now click on Free to delete the existing bake. And then hit Bake All. Now let's press escape and cancel the bake in the middle just to ensure that everything is working properly. And that's how the adaptive domain works. And so far so good. So I'm going to resume the bake and then bake all the 1200 frames. Alright. All 1200 frames have been baked. Now let's scrub through the timeline, take a look at some of the important frames to see how the smoke looks. Everything looks good, so we can proceed to the next step of dynamic paint. In order to get the skid marks, let's try and use dynamic paint. Now, if we select the bumpy road mesh that we have, then it has a few million vertices. So if we try to unwrap this, the system is literally going to cry. So let's create another ground plane. And let's add in a mesh and then add an array modifier and then a curve modifier and then use the NURBS path as the curve. And then let's apply all transforms. And this has been discussed in quite a few of my tutorials, so please take a look at it. Now let's use this simple plane as our dynamic paint plane, as the number of vertices are very low. Now just to ensure that the proxy mesh is slightly below the ground plane so that there is some sort of intersection between these two. While the wheel proxy mesh is selected, let's head on to the physics tab and let's add dynamic paint. And then let's change the type to brush because this proxy mesh is going to be the brush. And then let's leave all the settings on default. So the proxy mesh that we have for the wheel is going to be the brush. And the ground plane that we just created is going to be the canvas. And for the dynamic paint plane that we just created, the modifiers have to be applied. So let's apply those modifiers. And now let's jump into edit mode. Cool. So we just have very few. And instead of 1.5 million vertices, we only have 50. So now it's easier to unwrap. So select all of the vertices and then hit unwrap. So now this mesh is neatly unwrapped. Alright, let's go to the UV editor. But as we can see, all of the vertices have been unwrapped one on top of the other. And that's not how we want it. So let's select all the vertices by selecting A and then hit unwrap. So that way, the mesh neatly unwraps onto the UV map. Now we're going to use this UV map to create our skid marks using dynamic paint. So that's the UV map that we're going to use. Cool. So now let's select this dynamic paint plane and let's jump into the physics tab and then let's add in a dynamic paint. And then the type is going to be canvas. And then let's change the format to image sequence and the resolution I'm going to use 2K resolution for it. And then I'm gonna check on the anti-aliasing. And then frame start is gonna be 250 because that's when the drift starts. And then the end is gonna be 750 because that's when the drift ends. And the sub steps, I'm gonna go for the maximum, which is gonna be 20. And the reason why we need many sub steps is because we don't want the skid marks to be discontinuous. We want it to be a continuous one. So we need 20 sub steps for it. And then let's uncheck any of these special effects like dissolve, dry. And then let's jump directly to the cache path. And then let's rename it to something we can recognize. And then let's check on the UV map and select the UV map that we just unwrapped. And then the file format is going to be PNG and the pre-multiply alpha is checked. And then let's check on the paint maps. So those are the settings for the canvas. Cool. So the proxy mesh for the wheel is going to be the brush. Both the rear wheels are going to be the brush and this is going to be the canvas. So let's bake the image sequence. So now the image sequence is baked onto the UV map. Now that we have the dynamic paint image sequence already baked, let's see how to texture the skid mark. Let's split the screen and then change the editor type to shader editor. And then let's add in a new material. So that adds this principled BSDF as the default. To this, let's add image texture. So the image textures we're going to use is from AmbientCG.com. And we're going to use this asphalt 10 and then asphalt 15 images. So one is for the road and the other one is for the skid marks. Obviously the darker one is for the skid marks and the lighter one is for the road. Alright, so the way we're going to do this is by adding image textures. So let's add an image texture node. Let's first duplicate it and then hit open, and then let's point these to the appropriate color files. And then let's rename these nodes for our reference. Cool. Now we got to mix these nodes. So let's use a mix RGB. And then color to color 1 and then color to color 2 from the other texture. And then output of the color to the base color. So there we go. Cool. Now we need to change the scale of it. So let's add a mapping node. And then let's add a texture coordinate node. Now let's connect the generated from the texture coordinate to vector of the mapping. And then let's add in a value node and connect it to the scale so that we can work with the value. I think the value of 20 works. And let's duplicate the mapping and the value node and then connect it to the other texture. Cool. So now let's add in another image texture, and to this let's add in the dynamic paint image sequence. Now let's hit auto refresh so that it refreshes for each frame, and then let's connect the alpha of this image sequence to the factor of the mix node. And then let's have the UV map as the input. And then let's change the start frame to 250 and the offset as 250. There we go. So now we should see the skid mark textures. So these textures are updated as per the dynamic paint image sequence. So at frame 200, there's no baked image. And between 250 and 750, we have the baked image sequence, so we can see skid mark. Now, when we go beyond 750, we see a slight problem. And that is, we lose all the textures. And the reason for that is we don't have any more frames after 750 baked into the image sequence. So let's pick the last frame, which is 750. And then we want this image sequence to stay without being refreshed for the rest of the frames until frame 1200. So let's add in an image texture. And then let's just have one image, which is the last image. And then let's connect the UV to vector and then output to the factor, which is the alpha to the factor. So that way, for every other frame from 750, we're just going to have the same texture. So that way we don't lose the skid marks that were already created. With cycles as the render engine and 8 samples for the viewport and 256 for final render, let's head on to the render preview. And as we can see, there's no background light. So let's head on to the world tab, and then under color, let's add a sky texture. And in this, let's change the strength to 0.2. And that's the lighting that we are interested in. Under render properties, let's check this transparent box. So now our background is transparent. We still have the lighting, but the background is transparent. Let's uncheck the camera to view. And let's move this camera to the position that we are interested in. Since we've been working with this file for all our tutorials, the camera position must have been changed at some point. That looks good. And then let's switch on the denoise for the viewport. And then I'm going to select albedo and normal as the denoise passes. All right. And in the under input passes, let's select the denoising data. And let's head on to the compositor editor. And then let's add a denoise node. And then to this denoise node, let's have the image to image, and let's connect the denoising normal to normal and then denoising albedo to albedo. And then let's also add an alpha over node, as we are interested in getting a black background. Cool. Now let's connect the image to the second image, and then the color of the first image, let's change it to black. And then the output of this alpha over to the image of the composite node. That's how we get the final render, which is black background, but with the sky texture lighting. Let's head to render properties, and then let's make sure the 256 samples is turned on. Now let's turn on motion blur. And for the smoke, now let's get to the shading for the smoke. So I'm going to go with the Khaos fire shader. And let's hit home. There we go, that's the Khaos fire shader. I like this shader a lot because a lot of the work has already been done for you. And let me get to the render preview. And here, the drift smoke is a bit thick for my liking. So I'm going to reduce the smoke density in the Khaos fire shader node. And I'm going to go with the smoke density of 10. And then the smoke contrast of 0. And the smoke color, I want it to be much whiter, because typically most of the drift smokes are white in color. Cool. So that's sort of the look that we wanted. The simulation has 240 FPS, but our animation needs to be 24 frames per second. So for this, let's take every 10th frame of the simulation for rendering. And also, since we also need slow motion, let's divide this into 4 distinct sequences. So the first sequence is going to be frame 1 to frame 400 at a step of 10 in the frame range. And sequence 2 is going to be frame 401 to 500 at step 1, as we want the footage to slow down by 10x here. And then sequence 3 is going to be frame 501 to 750 at a step 10. And here the dynamic paint will refresh at every frame. And then the fourth sequence is going to be frame 751 to frame 1200 at step 10. Here the dynamic paint will be of a static image of frame 750. Sequence 1 is going to be at a normal speed at 24 FPS, and sequence 2 will be slow motion when rendered at 24 FPS. And then sequence 3 is also going to be at normal speed, and sequence 4 is also going to be at normal speed. So we render the animation as PNG images for each sequence, and then use the Blender video sequence editor to render the entire footage. So I'm going to render out these 4 sequences, which is frame 1 to 400 every 10th frame, frame 401 to 500 every frame, and then frame 501 to 750 every 10th frame, and frame 751 to frame 1200 every 10th frame. And all 4 sequences are rendered at 240 FPS, as the Mantaflow simulation has data at 240 FPS. The 24 FPS rendering is only in the Blender video sequence editor to render the entire footage. So let's jump into the video sequence editor of Blender, and then let's add an image sequence. I'm going to choose the main shot, and then I'm going to press A to select all of them. And then at 24 FPS, 210 is the end frame. So since every 10th frame of 240 FPS is rendered, it appears at a normal speed. And then since every frame at 240 FPS has been rendered between 400 and 500, the footage has been slowed down for those 4 seconds. That's how we get this beautiful slow motion. And then we're going to have the file format as FFmpeg video, and then encoding with the video codec H264 and perceptually lossless. And then there's no audio in this. I'm going to mix audio later. So those are the settings that I used. So if we are to cut and move any of the parts of the sequence, we just use a shortcut K or split, and then we can just move the strips around. And we can also add speed control for any strip, and then change the speed control to multiply, and then here we can either ramp up or ramp down the speed. There we go. So those are some of the basics of using Blender's video sequence editor. So let's get back to where we were. And then I'm going to render this animation, and then that's how we get this nice shot that was shown in my animation trailer. And we can go back to where we saved the file and then just play it. There we go, that's the video file.
Thank you for watching. I hope you like this video, and if you do, please consider subscribing to my YouTube channel.